Cool.
Yeah, here we go. So happy Friday, everybody. Today is May 20th, and this is episode 21 of our Google Hangouts and podcast on all things DOCSIS. I'm Brady Volpe, founder of the Volpe firm and Nimble This. With us, we have the Deacon of DOCSIS, one and only John Downey, CMTS technical leader at Cisco Systems and computer guru here. John, good to have you back.
Hey, thank you. I'm trying to get my headphones set up here. Sorry.
Yeah, you sound great as always, John. Good video, good audio. It's going well.
Prepared well.
Yeah, right on time as always. So we've got a great show today. We're going to be talking about DOCSIS 3.1, practical applications and stuff. Also have some miscellany I want to cover, things in the news. There's a lot of companies making announcements about DOCSIS 3.1 rollouts. So, of course, we know Comcast is deploying in 6 different markets. There's European operators like TDC announcing that they're doing DOCSIS 3.1 rollouts. By the end of 2017, they're supposed to cover 1.4 million homes in DOCSIS 3.1. So that's definitely getting its momentum going. Charter's closed the deal now with Time Warner and Bright House Networks. They're going to serve more than 25 million customers across 41 different states. So they're getting, their Comcast is 27 million customers. So they're trying to catch up with. John, I don't know if you have anything to add on that merger or not, but.
Yeah, I mean, I was thinking about that. I just got back from Boston to the INTX show. It used to be the NCTA show.
It's in excess, right?
They're still looking for a lead singer. I gotta wonder, it's like, when does that show become the way of the dinosaur or the way of the Western show?
Yeah.
They try to combine it with the emerging technologies. So it has set good workshops and sessions, but the show floor, something's got to change, right? The way we do business now, and the reason why I thought about that is you just talked about Charter, Bright House, Time Warner merging. The less MSOs we get, the less you're going to have attendance, unless those big MSOs let their employees go.
Yeah, there's a lot of cost and a lot of time taken away from sending people to shows like that. So they're only going to send a fewer percentage of their resources to these shows. I think we're going to see the same thing in things like SCT Expo. We see that attendance start drop and stuff. So we're going to see the same thing at these smaller shows. And people are going to say, we're going to do one show a year, and it's probably going to be SCT Expo.
But think about how this shows where this show falls. I mean, this show falls. It just happened, and like you and I, we're going to ANGA in Germany. So if you're a big, you have to supply, resources for both. So it becomes difficult for those 2 shows. And then if you do CES and SCTE, and so, and I'm not even privy to everything that goes on behind the scenes, but I go to the show and I see the attendance, and it seems like at what point do you have more vendor attendance than you do outside attendance?
Yeah,
you have vendors just looking at other vendor stuff. Handing out like trick or treat and going to each vendor's place just to get a free ball or something like that.
Yeah, so you can tell me about anything exciting you saw at INTX. I didn't go. I did see one announcement that intrigued me. It was the Nokia Bell Labs announced the world's first 10 gigabit per second data speed over traditional cable access. It's basically a cable that they came up with. They call XG cable. So I like the name of it. It's pretty cool. And they say by using this technology that operators can effectively use existing HFC cables over the last 200 meters to provide unrealizable upstream speeds. So basically, the way I understand this is basically like monster cable, that you can get at like Best Buy for the cable industry. So it's just really high-speed coax cable that goes to high frequencies, super high frequencies. And so I don't know if you saw that at INTX while you were there. There was, a couple press releases that basically gives us 4.0. We talked about that a couple shows ago, but this would give you from, say you go, from a node or an amplifier to the home, you can give this full duplex DOCSIS. So
I think that's the key right there. It's trying to tie in with the full duplex, FTX,
Yep.
whatever you want to call it, where you have no diplex filters. The upstream, we know we can get a lot of speed on the downstream with DOCSIS 3.1, and even if we go to 1.218 gigahertz on the downstream, we might be able to get 3, 4, 5 blocks of DOCSIS 3.1 at maybe 4K QAM. Looking at 4 to 8K QAM, 5 blocks, that's basically a gigahertz of spectrum, 200 to 1.2 gig. We're looking at 10 gig of speed right there. But on the upstream, that becomes our bottleneck again. There's no way we're going to even get it close to symmetrical speeds. Even if we did 5 to 85, I have a European customer looking at 117 megahertz in the upstream. Most people don't even know about that split, like a 117, 150 split. But the other split that people are looking at is 204, 254. It's like, why would I do that when maybe full duplex is out by then? But to do this full duplex, I need another new CP, not even DOCSIS 3.1, a new modem past DOCSIS 3.1, and we haven't even deployed DOCSIS 3.1 yet.
DOCSIS 5.0.
$1 million. So, the way I see things playing out is we definitely need an HFC upgrade, and that's probably going to be a deep fiber architecture, node +1, node +0, a node that can be upgraded to remote PHY. What we do with that last bit of coax, if we can get rid of diplex filters, we might be able to deploy an FDX type of solution to open up the upstream and do this full duplex. But this might be 7, 8 years down the road, whatever it happens to be. Because I'm going to invest in an HFC upgrade, probably, I think, 85 megahertz in the US upstream. And then I think 1.2 gig on the downstream. Specialized taps, whatever, to make things levels equal. There's a lot of stuff to decide there. But then it's going to have to be, if I do the full duplex later on, it's another CPE device, because you're getting rid of all the diplex filters. You're letting the upstream and downstream use the same piece of coax. In my new modem, I'm going to have some type of echo cancellation where whenever I transmit upstream, my downstream filters it out so I don't bleed into myself, my modem. Right. And then I have to wonder if I am on the same tap, if you want to call it a tap or whatever, as my neighbor, when I transmit upstream, his downstream has to stop. So on the same tap, you're going to have half duplex. Now, if it's 10 gig half duplex, you still get 5 gig up, 5 gig down, so who cares, right? I mean, it's a huge speed. But on the common cable, where everyone is, it would be full duplex. Gig up, 10 gig down. And if you did remote PHY, you could have a 50 dB downstream MER because you have no amplifiers, you have no fiber deep. I mean, it's all doable. And what Nokia showed, I mean, they're just showing the capability of what coax can do. I don't even know that they were showing some special cable.
Yeah, I mean, I just think it's amazing after all this time. We're still innovating on coax cable. So I think that's a pretty cool thing. And to your point of, we're talking about gigabit speeds and that's phenomenal. I do remember a time when you and I were working at C-Core quite a few, 25 years ago, when we were debating whether or not C-Core as a company should get into the cable. And, there was executives saying, who is ever going to need 10 megabits of speed on a we had dial-up modems at the time. So it really shows you, 10 megabits of speed seemed like an absurd amount of speed at the time. Now we're talking about 10 gigabits of speed seeming like an absurd amount of speed. But I think, in 20 years from now, 10 gigs of speed will seem like, well, that's just nothing. Because we'll be talking about terabits of speed over the network.
Yeah, if we don't learn from history, we're destined to repeat it, right?
Absolutely.
I mean, that's been going forever. Moore's Law, every 18 months, everything doubles the speed and half the price or whatever it is. And it hasn't stopped. And even when people keep throwing around the CAGR number, the compound annual growth rate of 25, 50, 30, 50%, I'm like, at what point does a percentage of a high number become even higher? And I think, and I kept thinking, once I get to 100 meg, 50% is 150 and then blah, blah, blah. It's like, it's a lot. Like 50% CAGR of 1 meg, no big deal, right? But 50% of 10 meg, 100 meg, it's exponential or whatever you want to call it. So it's like, it's
or 50% of 10 gig is a lot.
Yeah. So then I'm like, and I kind of doubted it, but we keep following it. Every year we keep following it. And all it takes is like some other application to come out. And now we're looking at over-the-top video. The question will be, what's the killer app on the upstream that forces us to do stuff with the upstream, right? It's like, is it just a marketing ploy where we want to offer symmetrical speeds, but no one's really using it? You know, what are we doing on the upstream? Is it Periscope? Is it home security? Is it, high-def cameras in your house for home security? You know, what are we doing on the upstream what's going to be the killer app that pushes upstream?
Yep, there's a lot of cool things going on there. So a couple more miscellany. I have Cable Labs, the Ingenious Working Group, which is the P&M working group at Cable Labs, Proactive Network Maintenance. They have 2 new papers that they came out at INTX. One is they developed a novel method to locate signal leakage in the cable plant using both the phase and magnitude of basically a continuous wave signal. And they combine that with GPS, Global Positioning System, and it produces the latitude and longitude coordinates of cable plant defects. So it's something they've been working on for quite some time. It's a nice little system. It's kind of a low-cost signal leakage system. So they have a paper on that. I think. So
if you want downstream generation, so generate in the head end.
Yeah, generate. Well, they can. Yeah, just do a CW signal in the head end. So, but it's a really nice system. They have a nice demo. You can you drive around in the vehicle, but it's a different way of doing signal leakage detection. The other paper that they have is they demonstrated a new time domain reflectometer, or TDR, that is basically looks at signals in the cable, any cable modem that has full band capture. They look at standing waves that you have, and then they do an inverse Fourier transform on those ripples, and they can very accurately determine where plant impairments are that would come from things like corrosion, animal chews, stress fractures on the coax cable, anything that's going to cause anytime that you see like the little ripples and stuff, it creates a standing wave on your forward path channels. And so they can very accurately determine the distance to where and locate where that impairment is. So we're just adding more capabilities to our proactive network management solutions, or network maintenance solutions.
Almost we can use the same formulas we use on the upstream for distance to fault, or distance in the cavity, or distance between 2 faults of a cavity.
Yeah.
492 times loss propagation. We used to call that FDR, right? Frequency division, or frequency domain reflectometry, not really TDR. So I'm wondering why Cable Labs didn't decide to call it FDR, unless there's a problem with JDSU VIAVI, because they had the old CLI 1750 device, I think it was called, that did FDR, frequency domain reflectometry.
Yeah, it's just it's the same technology. The thing is, we just have millions of modems out there that are deployed that have full band capture capability, and we can pull those modems. We see a standing wave. We can very quickly triangulate in on where the leak is. So it's a good paper. It's good. It's the technology is not necessarily new, as you're saying. It's been out there for some time. It's just we're able to take advantage of it in all the DOCSIS 3.0 modems that have full band capture capability.
But as well as I, it's only the 3.0. I don't think any 8x4 3.0 modem has it, right? I think it's all the newer modems, like the 16x4 or 24x8, and 32x8 modems.
Yes, there are 8x4s that have it. If they have the Broadcom 3380 chipset or higher, and I think it's the Puma 5, Intel Puma 5 chipset and higher, if they have the right firmware in them. So there's like that caveat. You got to get the upgraded firmware in them.
Did Cable Labs come up with a generic terminology? Because isn't Broadcom FBC a Broadcom term? Full band capture?
We've gone back and forth on that, and I think we settled. We came to the conclusion that FBC was not trademarked. We can use full band capture. We were going down the route of saying, I think it was CPE capture or something, some terminology like that. But full band capture. We're allowed to use that. Once again, we thought we couldn't use it, and we realized we can use it. So it's cool.
Okay, good. So going back to your first, I want to comment on the first thing you talked about was the CW generation with maybe some phase or amplitude modulation on the CW for leakage. I know Ron Rannick is on a working group as well. how do we translate that into a remote PHY solution? Because there's no RF in the head end for a remote PHY solution, because the PHY now will be out in the field at the node. So that node has to generate this CW carrier, or that node has to generate CW with some modulation on it to distinguish that it is a CLI carrier, something for me to test CLI.
Yeah, that's a good question. I have to take that back to the Genius working group and ask, how we would be doing that in a remote PHY solution.
Yeah, I mean, even when we do remote PHY, like Viavi, which is the old JDSU, their path track's not going to work anymore, right? I mean, there's no upstream RF. It's all digital out there.
There's a lot of work going on right now to make sure that any type of remote PHY solutions, no matter who the vendor is, supports things like upstream capture, upstream spectrum analysis, because that is extremely important, because you don't stick a path track solution or any type of return path big box monitoring solution out in a node easily,
or even downstream sweep, right? You won't have any sweep points.
Yes,
inject any sweep.
All the traditional ways of testing the plant that we've used in the past historically really go away, and P&M then becomes extremely important for us to have those type of solutions out there for remote PHY.
I agree. You talked about, as long as we've been in cable, and cable TV started in 1948. We've been in it for a long time. And we still come up with like the simple things that can make a difference. I ran into Brad at Holland Electronics at the show, and he was showing me his F connector. F connector. How long has an F connector been around, right? It's like, what can you really do with an F connector or an F81 barrel? It's like, how can you really change it?
Are these the self-terminating ones?
They're sort of self-terminating, right? They're spring-loaded.
Yeah.
So I wouldn't call them self-terminated. More like it's a pin. Say you have an F connector with a pin. So it's a pin connector, not a feed-through connector. When you disconnect it, say from the wall plate or whatever, it's not just an antenna sitting there. The pin kind of pushes away, so it's more like an open. And I asked them, it would be cool if once the spring load pushed away, that internally there was a 75 ohm resistor to ground.
Yeah,
that would be more space, cost, blah blah blah. I said, because you're pushing away the antenna and the ingress source, but you still have a micro reflection, right? You have reflections. So all these unterminated, they're like unterminated drops. It's basically like having F81 barrels everywhere. But he says, in a big conference hall like we were in Boston, you could have 300 drops go into all these booths that when they up and leave, and the booth just has all these cables hanging. So you have the accumulation of all these drops of ingress. Whereas with these connectors, you don't have to worry about people like terminating and stuff like that. Yeah, there are opens, but it's better than having ingress egress antenna.
Yeah. The ingress is really the big problem they're trying to solve there. So that is a nice solution. I've seen those connectors before, and I think they're a great idea. I do agree having the 75 ohm termination on it would be nice, but at least getting the connector pulled.
Can't have everything.
Yeah, where'd you put it?
Yeah, we can't have everything. Can't have everything, I guess.
Yeah. So, okay, on to DOCSIS 3.1, we wanted to talk about a couple of different things. One of the things that I have been hearing from a number of operators that are sort of hesitant to even look at DOCSIS 3.1 is they're hearing things like, well, they have to replace all the equipment in their plant. They have to change splits, and they're concerned about peak to average power ratio. And I wanted to clarify some of those things that, initially we were worried about peak to average power ratio. I think we talked about that last week or last podcast with Ron, that, peak to average power ratio is something people were initially concerned about at the very beginning. And what that is we have these pilot carriers. I think you were going to talk a little bit more about those, but pilot carriers are at a higher power level than the average subcarrier in the OFDM channel. And we were concerned that these pilot carriers were going to cause, have too much peak power versus the average power of the channel, and that would cause overdriving of RF amplifiers, the hybrid gain blocks, and we would need to upgrade the amplifiers to gallium gallium nitride amplifiers, and so we just have to replace everything. And what we found out over time was actually, these pilot carriers, there's so few of them that the peak power just gets swamped out by the average power, and it's really not a problem. So that kind of said, no, we don't need to replace all the RF equipment out there.
I mean, a big concern was downstream laser clipping.
Also laser clipping.
More so than amplifier compression.
Yep.
And then Ron ran some numbers, and he found out that even though the pilots are 6 dB higher than all the rest of the sub-carriers and even a 192 megahertz OFDM block, that it adds an average power of maybe less than a dB.
Yeah, so it's basically a moot point. Don't worry about it.
Yeah, so it's really not that big of a deal. And that's not really going to be a concern. My concern would be more like upstream laser clipping. Hopefully there's no FP lasers out there, but even if I have DFB lasers on the upstream, all analog lasers are not digital reverse. If I start doing OFDMA, DOCSIS 3.1 upstream, how is that going to affect me? And that's still the unknown,
So, and that's a good point to bring up. First, you can run DOCSIS 3.1 and you don't have to do OFDMA in the return. You could still do DOCSIS 3.0 mode in the return. But if you wanted to do OFDMA in the return, a lot of people think, I have to do like 96 megahertz of spectrum in return. But the return, the DOCSIS 3.1 specification allows you to do an OFDMA channel in a return as small as a 6.4 megahertz bandwidth. So you can do a really small OFDMA return channel just to start experimenting with it in a return, and take that capability or the increased modulation capacity of DOCSIS 3.1 in return. And so one of the things I'm telling people is you can do DOCSIS 3.1 in the downstream and in the upstream without making any changes at all in your plan, and take advantage of what DOCSIS 3.1 has to offer. And I think that's why we're seeing so many cable operators starting to say, hey, we're deploying DOCSIS 3.1 now, or making plans to do it within the next year.
And there's a lot of field trials going on. You and I are going to Germany in a couple of weeks, and I'm talking about spectrum allocation for DOCSIS 3.1 and why and why not, or pros and cons of doing different splits, what they might do in USA versus Europe. And there's a lot of options there, and it's still analysis paralysis. We sit there and analyze everything. And it's like, all right, what do we do? Because it's a big decision. It's going to take a lot of money. And you might say, let's deploy DOCSIS 3.1 and don't do anything to my plant, which is perfectly fine. On the upstream, it becomes a pain. What are we calling it? A and FT, amp, or what is it? Time and frequency division multiplexing.
Yeah.
On the upstream. F and T. F and T. It sounds like you're swearing at somebody. F and T. Is F and T. Frequency and time. I think they turned it around and said T and F, or I don't know what it is. Time.
Or is it T and A?
It's one of those. But it's sharing the upstream spectrum, right? It's like letting 2.0 and 3.0 modems burst whenever they need to burst, and to have a 3.1 modem burst, because it's all bursty. You could have, when the 3.0 and 2.0 modems drop, in that same spectrum, you could have OFDMA.
Which is coexistence. Which is coexistence in the specification. So it allows them all.
So you're just making more, and you're making more complexity in the CMTS, right? Because it has to schedule the time and everything else. And in a 5 to 42 megahertz, that's probably going to be a necessity, because I don't have a lot of spectrum to work with in the first place. And the only reason to go to 3.1 in that 5 to 42 is I know I could do lower modulation. It's more robust from 5. Maybe I do that 6.4 megahertz minimum channel you just talked about from 5 to 11.
Yeah,
megahertz.
And you have the benefit of LDPC, low density parity check, which is the much more advanced replacement for Reed-Solomon error correction. So when you have a lot of impulse noise and ingress in that sub 20 megahertz range, that's a great place to put an OFDMA channel, because you might actually be able to get pretty reasonable data throughput in that really noisy region where you have a very robust error correction. And you also have subcarriers that are very small. They're 25 or 50 kilohertz wide, so they can run at different order modulations in there, and you can get some reasonable throughput. You never could put a 3.2 megahertz QAM in some of these noisy areas that have just Reed-Solomon error correction, because they're just going to drop packets of data and perform them. They may not even, you may not even have a modem be able to register in that area.
You might you'd have to run QPSK, and at that point, it's like, what's the point? I mean, your throughput is so low. It's kind of like, what's the point? So, I mean, I running some numbers, 5 to 42, running maybe 16 QAM in the low end, 64, maybe at the very high end, and 256, or 1K QAM in the middle, where because some of these systems have a good MER. And you could probably get close to 300 megabits per second. Whereas if you look at that same spectrum with ATDMA, 4 ATDMA channels, that's 108. Yeah. So that could potentially get you 3 times more speed, 300 meg, maybe offer 150 meg service on the upstream. And I think that's where it's coming to, right?
This is without, potentially without making any changes to the plan. I think the key concern could be the return path transmitter, because that becomes the weak link, where we could have laser clipping. So the remote PHY then really becomes a nice solution to get rid of that return path, the analog laser, and replace it with a digital laser when we start to make a change there. So now maybe the change becomes, if we want to take full advantage of 5 to 42 megahertz without changing out the rest of the plant, is just replacing the fiber node with a remote PHY. And we can really, as you say, go from 105 megahertz to over 300 or 105 megabits per second to go, or to, upwards of 300, 350 megabits per second. That's a significant change without making changes to the rest of our plant and going to an 85 megahertz or 200 megahertz split. Within the next 1 or 2 years, we could push that off for 3-4 years. That's a heck of a gain.
Yeah, but the big problem with remote PHY up front is you basically have to have an all digital lineup. There can't be any analog video channels, right? I mean, your downstream video has to be all QAMs, basically, because you're going to be generating all those QAMs from the node itself.
But you talk to a majority of carriers today, or operators today, and they're headed or having the migration plans to go to all digital. And some of them are talking about going to, how do I get to an all IP solution? Because they just, if they're looking at going to all digital and going all MPEG, they actually want to figure out how to get to an all IP solution.
I thought it was ironic how Comcast, talked about analog reclamation, and they started using the term digital reclamation, going from MPEG 2 to MPEG 4. You get even more compression, right? Yep. So, there's a lot better compression. And we talked about the next compression past that was like HEVC or MPEG 5. I don't know what you call it. Yeah. What do we call it? HEVC? H264?
Yeah. There's some acronym or initialism, but it's just more is better. More is better.
If Ron's watching, he would say abbreviation. Abbreviation is the generic term for acronyms and initialisms, or something like that. So, what else did I see? INTX. I didn't see a lot of people walking around. Even Cisco, we didn't even have a booth. We had a suite. So basically, we didn't have an open booth that people could just walk in. You had to be invited in and brought in with a Cisco employee. And that's what it seems like the INTX is becoming. Is more. It's always been suits, right? The NCTA show is always suits. And then the suits and ties, not so much ties anymore, but it's all the higher end guys, CTOs, CEOs, stuff like that, the decision makers, the money guys. Whereas SCTE is all technicians and hardware and stuff that you can deploy today, showing people how to optimize stuff. So if it's all suits at these shows, then having suites makes more sense. At what point do you stop having open booths? It's like, what's the point?
Right.
Yeah, and that's why I'm wondering about this INTX show. It's like, how long before you figure out that it's a shift in how we do business? Do you make it more virtual? Have a GoPro and people walk around and people can attend virtually?
Yeah. There are a couple virtual shows which I've attended. They don't go over so well. They're kind of lame.
You can't control a drone. You can't control a drone remotely. No. Just fly over top.
Yeah. So.
But that one came and went. And back to the 3.1 stuff, and we're going to talk in Germany and ANGA on DOCSIS 3.1 spectrum allocation. I'm looking at the 5 to 85 megahertz on the upstream as a good option in the U.S. It still allows me the downstream to do the legacy MPEG-2 set-top boxes. I know some of them have a downstream control channel for the MPEG, the set-top box, and they are frequency agile, but a lot of systems are focusing on a 104 megahertz downstream control channel for those millions of legacy set-top boxes. So that right there is restricting me to upgrade to even a higher split on the upstream. Because if I increase my upstream split, it decreases my downstream, meaning I eat into my downstream.
Right.
And that's the controlling thing there. It happens to be some of the legacy set-top boxes. So even the 85-105 split is actually dropped down to an 85-102 split. So you might see diplex filters that say 105, but they're probably more like 102. That way the 104 downstream can still get through the system and control those millions of set-top boxes. So the 85-102 split makes sense. Digital reverse before I go remote PHY, EDR, the enhanced digital return, that gets rid of laser clipping as well because you're digitizing the upstream. You could still have A to D clipping though. So if you have a lot of ingress and noise coming in, your A to D in the node itself could have some clipping there. So that, I mean, there are some things we have to make this stuff work that might be more palatable as far as cost goes. The flexible solution taps, I think, they help a lot with upstream transmit level issues. I think
what is it? A flexible solution tap?
Taps. It's a tap with equalizers. It's a tap instead of just a reverse pad that they have equalizers or cable simulators in the taps. So it's almost like instead of just balancing your amplifiers, you would balance your taps as well.
Okay, so this is just to adjust the forward and return transmit power of the cable modems and receive power of the cable modems, right?
Correct. It's almost like you're trying to balance the tap for the cable preceding the tap.
Right.
So there's a lot of coax cable which has nonlinear loss. You take the tap and you try to balance that out so you're coming almost flat on the downstream out, and then going in, you're transmitting close to 43 to 45 dBm.
Yeah, okay. I just not heard that term used for them before.
I think it might be a Cisco term. FST.
Yeah, you guys come up with a lot of great your own names for stuff. So, but you're big enough, you can do that.
And sometimes it's just me and Ron. Or maybe it's just me. I make up names. See if it'll stick.
Yeah.
But back to the spectrum allocation. In Europe, a lot of systems are 65 megahertz in the upstream. So going to 85 doesn't make sense, right?
No. Their next logical jump is, their next logical jump is
204. But I ran into another European vendor that's thinking about, and this is a split. I think it's in the spec, but no one really knows about it or no one talks about it. It's a 117, I think 150 split. So it's 117 on the upstream, 150 on the downstream.
Yeah,
so
about double
the reason why I like it. Yeah, so if you're 5 to 65, that's only 60 megahertz of spectrum. From 65 to 117, that's another, 50? So you're almost doubling your spectrum without going too high, eating into more of my downstream. And to do a 204 upstream, that's going to be a lot of coax loss if you plan on using anywhere above maybe 120 or 130 anyway because of the coax loss. So your upstream transmit levels are going to suffer quite a bit. And we always talk about, it's like, what are we going to do in the upstream? We don't have AGC in the upstream. On your downstream amplifiers, you have it. Well, in Europe, maybe they're node +1, so they don't have a lot of nodes anyway. A lot of underground, right?
I was going to say, there's so much underground. I don't think it's going to matter for them. And so,
remember, like when you and I worked at C-Core, we had special amplifiers.
I try to forget those days.
all the housings had all the connectors on the bottom, right?
Yeah.
That way, because it was all underground, so it's easy to go in and out on the bottom of the housing. But it's all underground, so temperature's not a big concern. But you still have all the coax loss. You have all the splitters. You have all the taps. So higher frequencies on the upstream are going to have more loss. So now I need modems with an even higher transmit level, unless I have this flexible solution taps. So if I have the taps to help balance this out, that'll help. We even talked about 5 to 85 megahertz. If you do have 3 or 4 amplifiers in cascade, I would opt for the thermal equalizers on the upstream.
Yeah.
Not just regular reverse EQs, but thermal reverse EQs, especially if it's aerial cable.
Or if you have the Nokia XG cable, that solves all these problems. Zero loss.
Zero loss. Super collider, superconductor.
That's right.
It's cold, super cold. It's like a magnetic train or whatever you call it,
Yeah.
a magnolift.
So what's your paper on for ANGA? What are you talking about at ANGA? That's
So
the second week in June or second week in June.
You know, my goal was to talk about capacity planning with DOCSIS 3.1 involved. And it's what I talked about SCT last year in New Orleans. Is that where we were? New Orleans?
Yeah. Not New Orleans.
Okay. Yeah. So the goal was to talk about that, but it's so much content. I'm like, we looked at how many people were in my session. We got 75 minutes. 15 minutes for Q&A. So that's 1 hour. And they just threw in another person into my session. So it's me, someone from Aris, Jack Moran from Huawei, Future Huawei, 2 local operators in Europe. That's 5 guys in an hour. So that gives me what, 12 minutes? That gives me half a slide. That gives me an intro. And that's about it. I'm like, my name's John Downey. Have any questions? Catch me later. So I'm hoping to go first so I can take all of Jack's time and all the other guys' time.
Oh, that's going to be a brutal time for everyone but you. Yeah.
So I cut down my presentation to focusing just on 3.1 spectrum allocation. Just talking about spectrum, upstream, downstream, what type of splits, what are my problems, pros and cons. And you know, there might be things that people keep forgetting about. Like downstream, we go past 1 gigahertz, and downstream, are you doing MoCA? The channel D1 of MoCA is 1.15 gigahertz. Is that going to be a problem? Maybe. Maybe I need filters in the house, so MoCA doesn't affect the 3.1 modem, and the 3.1 modem doesn't affect MoCA.
Is MoCA equally deployed in Europe as it is here?
No. And so that's going to help me over talking about this over there. They won't have to worry about it.
Don't spend a lot of time on that.
I'm like, you don't have to worry about MoCA, but keep in mind cappuccino. But there might be that LTE. LTE might be just for 4G cell phone.
Yeah.
700 to 800 megahertz. I found out also in Europe. I talked to one of our European SEs or sales engineers, and he said, we talk about remote control cars and stuff being at 27 megahertz, 48 megahertz, whatever. Garage door openers are at like 315. They have some boat navigation, I think, in some of their boats and stuff that are 400 and some megahertz. So there might be some frequencies, because we talk about digital off-air broadcasters, LTE, 4G cell phone, like what is potentially over the air that can get in? And it might be things you don't really know about or you don't think about. In New York, it used to be taxi cab drivers using old landline or mobile walkie-talkie stuff, 33, 36 megahertz and stuff like that. That stuff just kept getting in. Downstream, older, remember the old cordless phones at 900 megahertz. So there might be things that we don't think about because we haven't gone past 860.
Right.
Well, now we're going to 1 gig. Now we're going to 1.2 gig. Remember the old MC squared cable? Was that Times Fiber? Where it had a known suck out at like 530 megahertz, and then they changed the manufacturing process, and now it has a suck out at 1.1 gig. Well, now that you're not even, we might see it now. Maybe it's a good thing. I don't know. But it's like we haven't seen past 860 or 1 gig, so maybe we have to sweep it again to 1.2 gig and make sure. And 1.2 gig, some of our amplifiers and roll off and accessories. And
what's the stop frequency of JDSU sweep gear? Do you know? What's it go out to?
I think it's 1 gig.
I think it stops at like 1.02 gig or something. I don't think it goes beyond that.
Yeah, I think you're right. Yeah. So that's a good point. It's like, are they going to update that? Would people update it knowing that they might not be able to use that equipment if they ever go to remote PHY anyway?
Yeah, no, when I worked there, sweep was not something that we were investing a lot of resources in because it was working great.
As an operator, do you just say, let's almost go back to the old way of things and we'll just insert a few carriers out there and use the full bandwidth capture of the modems to see what's going on.
See if they're rolling off. Or you could even put a 192 megahertz OFDM channel out there and look at what happens to it, because that actually makes a great sweep channel. If it's flat,
fills the whole spectrum in, right?
Yep. If it's flat, you're good. If it's rolling off or sucking out, you're not good.
Yeah, exactly.
Because you can use a full band capture modem at the end of line to see what the quality of the end of line is then.
Yeah. So that's the type of stuff I'm going to talk about in ANGA, is the spectrum allocation, and try to focus on that. And then upstream and downstream. So 12 minutes. I don't know how much I'll get through in 12 minutes. Hell, we've been talking 45 minutes, right?
Yeah, we were only going to do 15, so. Yep. All right. Well, I'll be at ANGA. I'll be talking on implementing PNM.
Implementing PNM. All right.
Yeah. That's what I'll be talking about.
Hey, I got to do another selfless plug. Is it selfless? No, it's selfish. I'm going to do a selfish plug. I'm talking at Cisco Live in Vegas, July 13th. So there's 2 DOCSIS workshops, 2 hours apiece. Tuesday at 8 a.m. in Vegas. So 8 a.m. is not so bad, maybe. And 8 a.m. Wednesday is my session. We're talking about CBR8, features, troubleshooting, DOCSIS 3.1. That happens to go to Cisco Live. There's not a lot of cable guys that go to Cisco Live because it's a lot more expensive than SCTE, and it's very Cisco focused. But if anyone happens to be out in Vegas in July or is thinking about going to Cisco Live, check us out. So there will be 2 DOCSIS seminars that will be worth going to.
See, I was going to ask how you go to Cisco Live, how you get tickets to Cisco Live. I didn't know you had to pay for them. I thought you would just send me one or something.
I'll see what I can do. They usually have a good party too. I found out they have Maroon 5 playing Wednesday night.
Oh wow!
So they brought in Maroon 5. Yeah.
People should go to Cisco Live. Get to see Maroon 5.
Yeah, just for that, just for the party.
Yeah. All right. All right. Well, I think we covered all our topics. John, good seeing you. Thanks for hanging out. Everyone, thanks for joining, and hit the subscribe button if you're watching YouTube. Catch the podcast. Go ahead. One more thing.
One more thing.
You sound like the Apple guy.
I feel like I'm like one of those talk show guys, like Bill Maher or something. And by the way, I'll be at the Vegas Theater on April 29th, and then I'll be at Showtime and at Palladium.
Except you're not rich like them, so.
Yeah, really. I'm actually going to be at SCTE Southern California chapter in LA Wednesday. So I'll be out in LA Wednesday, and I'll be talking with the SCT Southern California chapter in LA.
That's a great chapter. Tell them all I said hi. I know a lot of guys out there. So.
Yep. So I'll be out there Wednesday.
Excellent. All right, John. So long.
A pleasure as usual.
Yes. Bye bye.